Good morning. In this lecture, we are going to discuss the topic switches in software defined network, that is the use of SDN in switches. So SDN switches can behave like a firewall, but they may not be a replacement for the real thing. Many people anticipated that enterprise organizations would adopt SDN technologies later than service providers or multi-tenant data centers and cloud service providers. We are now seeing more use of NVF, network function virtualization, within enterprises. An enterprise consider how to utilize SDN technologies in their data center environments. They start to consider what new security capabilities SDN can provide. SDN switches can drop packets for flows that are not permitted by the controller. SDN evolved from the concept of decoupling the lower level packet frame forwarding from the control function that intelligently determines how application traffic should be transported. That means the separation of the control layer from the forwarding plane, which allows networks to facilitate packet processing in new and innovative ways. And because of SDN, we could apply network virtualization. So SDN opened a new world of network design and enabled creative approaches to networking. SDN has also caused us to reconsider how security policies are enforced. Earlier, each security policy was enforced within each router, but now what happened was the security policy will be now allowed with the centralized system, and the centralized system will transfer it to the other places. So SDN evolved from the concept of decoupling the lower layer to the control layer that determines how application traffic should be transported. The separation of the control plane from the forwarding plane allows network to facilitate packet processing in new and innovative ways and created a new paradigm for network virtualization. SDN has opened up a new world of network design and enabled creative approaches to networking. SDN has also caused us to reconsider how security policies are enforced within the network. Now, in the open flow SDN model, the flows within a network switch are placed thereby by an open flow controller. If a flow is not present, then the switch puts the controller to ask to help how the packet should be forwarded. The open flow specification will later on tell how to do it. If the controller then determines if the packet should be forwarded or dropped. And then the behavior sounded like the SDN switch is behaving like a firewall, and enforcing that which is not included in the flow table is dropped standard security policy. This can be thought as similar to the default fail safe stance. Many SDN switches must behave like a standard Ethernet switch and flood traffic out of all ports of Ethernet frame designed to broadcast, multicast or unknown MAC addresses. Most SDN switches flood normal ARP traffic like a typical hardware-based Ethernet switch. In most situations, the default behavior for an SDN switch is to act like an Ethernet bridge or learning switch. However, it is possible to put an SDN switch into an explicit forwarding mode whereby only flows allowed or configured pushed by the controller are allowed. If every Ethernet switch could perform like traditional firewall, it would change the way security is implemented. If every Ethernet switch were like a multi-port firewall, then firewall policies could be implemented throughout the network at every ingress switch port and on every link between switches. There would be firewall for every server, desktop, every link, and the firewall policy would be implemented by a controller that maintains a global view of the current traffic and what traffic should be permitted. Having security policy enforced throughout the network would mean the complete erosion of the security parameter. Having that many security policies implemented and maintained manually would be an administrative nightmare. However, with a controller architecture, the policy would be created once and then pushed down to every network device for enforcement. So, network slicing. Network slicing is one of the most popular cases of SDN. A network can be logically carved up into logically separated overlaid network over the same physical hardware. That is network slicing. And the SDN can separate the networks similar to virtual routing and forwarding instances that may be used to separate layer 3 forwarding by using a slicing layer between the control plane and the data plane, thus making the security policies slice specific. The key concept of feasibility of using an SDN enabled switch as a firewall is the state it would maintain of the application traffic flows. So it will maintain ACL. Access control lists are not stateful and do not have awareness of when the connection started or ended. Even with the good old Cisco ACL CLI parameter established, the ACLs came only slightly stateful-ish. So that means ACLs are mostly stateless. So ACL does not pay attention to the three-way handshake, that is the SYN, ACK and ACK. On the other hand, observe the session, establishment and close process and apply using stateful inspection. So how do modern SDN products implement security and could behave like a traditional firewall? So Cisco ACI behaves in a stateless manner. The application network profiles configured in APIC are deployed to the switches in the ACI fabric in a stateless fashion. Therefore, an ACI system would not be able to operate with the same level of security as a standard stateful firewall. That is why ACI allows for layer 4 to layer 7 service graphics to be configured and integrated into the ACI fabric. So when it comes to open vSwitch, it has supported only stateless matches on policies. Project Floodlight is also stateless firewall. Then we have VMware NS6. NSX supports logical routing, switching, etc. And the firewall rules are there in the VNIC. It can do anti-spoofing and load balancing. So switches are not necessarily stateful. These SDN switches are unable to provide the same level of protection as a firewall. It is important to ask the vendor about the statefulness and the capabilities as compared to the firewall of the switches. So this was all about your switches in SDN.